Hey guys, this is Eddie the Magic Monk bringing you another maths problem. I know how much you like doing these. So the problem is to do with differentiation of trigonometric functions, which is quite a difficult topic. So here is the question. Find the shortest possible line that satisfies the following conditions. Number one end of the line must be touching the line AB. Number two, the other end of the line must be touching the line BC. And number three, the line must go through point E. So I will give you one such line so you can see what I mean. So if I just draw the line, so it says one end of the line must be touching the line AB. So line AB is here, so I'm going to make the line start here. The other end of the line must be touching BC, so it must end somewhere here, but because it has to go through point E, so I'm going to go through point E, and that will give me this line, right? It's touching, one end is touching AB, the other end is touching BC, and the line is gone through point E. So I want to know the shortest possible line that satisfy this condition. So for example, I could draw another one from here to here. Oops. From here to here. Right? Because the line starts here, starts on this line, goes through point E, and reaches point AB. Sorry, reaches this point on line AB. Now I don't know which line is longer. It's for you to figure it out of the two lines that I've drawn, but I want to find the shortest possible line. Okay, so I'm going to leave you guys to doing the work and come back when you are done. So what I've done is I've separated this diagram so that I can show you guys what you need to do. So if I just draw a very long line, okay, starting from line AB going through point E to the other side, okay, what I have actually created is two right-angled triangles, okay, because you can see if I draw a vertical line down, okay, from the first point, which is sitting on line AB, I will have a right angle triangle here. Okay, this is a right angle triangle, and we have an angle here which I'm going to label theta. Okay, let me just rub out this 3 meters because that's sort of distracting us. So we have an angle here, and we've just created another triangle down here, okay, another right angle triangle where we have the same angle, okay, the same angle in the bottom right hand corner. So this is also angle theta. Now we know that these two angles are the same. That's why we have labeled them with the same angle, because they are similar triangles. Okay, how do we know that they're similar? Because we have a diagonal line going through point E, and we know that both of these horizontal lines are parallel. Okay, both of these two lines are parallel, meaning that they're horizontal. So these two angles must be the same. Corresponding angles are equal. So that's why those two angles are the same. Now, if you guys remember the measurements that I gave you, okay, vertically down this top triangle is actually 3 units or 3 meters. And horizontally, this triangle has a side length of 1 meter. Okay, so now let us try and develop an equation for the length of this line. So let's call the length here L. L represents the length from here to here. Okay, the length of this long line. So L is equal to, alright, let's break it up into two parts. Let's break L up into the length of the top triangle. So let's go from here to here. Let's call that L1. It's from here to here. And L2 is from here to here. So L is equal to L1 plus L2. Right, the hypotenuse of both triangles. So let's have a look at what L1 equals. So if you guys remember trigonometric ratios, right, we got three ratios. We have sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. Now if we focus on this triangle here, we have sine theta equals opposite over hypotenuse. So we have sine theta equals opposite, which is 3, over the hypotenuse, which is L1. Right, so if we rearrange that equation, we can get L1 is equal to 3 over sine theta. Okay, and then if we look at the bottom triangle, this triangle here, we have cosine theta is equal to adjacent over hypotenuse. So cos theta equals adjacent, which is 1 meter, over the hypotenuse, which is L2. So if I rearrange that, I will get L2 is equal to 1 over cos theta. So now let's go back to our expression for the total length of this purple line. The length is therefore equal to L1, which is 3 over sine theta, plus L2, which is 1 over cosine theta. Alright, so just to remind you guys, L equals L1 plus L2, and we've said that L1 is 3 over sine theta and L2 is 1 over cos theta. Okay, so let's try to differentiate it. So therefore the derivative of length with respect to theta, if we differentiate it, okay, using the quotient rule, okay, if we differentiate it using the quotient rule, let's just get the quotient rule for you guys in case you've forgotten. So the quotient rule, I'm gonna write it up here. Quotient rule is f divided by g dash is equal to g times f dash minus f times g dash over g squared. That is the quotient rule. So if I do that on the first fraction that I have here, I will get sine theta times f dash. So f is 3. Actually, let's just write it out. Let's write it out. Okay, I have the first function here is 3 over sine theta dash. Okay, so we want f is 3, f dash is nothing, so 0. G is sine theta, and g dash is sine differentiates to cosine theta, and then g squared is sine squared theta. So writing that out will be g, which is sine theta, times f dash, so times 0, so that's gone, minus f, so that's 3, times g dash, forgot the dash there. So f, which is 3 times g dash, which is cos theta, over g squared, so that's sine squared theta. So that's what the first part is equal to, negative 3 cos theta over sine squared theta. That's the first fraction. And now let's repeat it to the second fraction. So we have 1 over cos theta differentiated is equal to, again we want to use the formula, so g times f theta, so cos theta, oops, we gotta do f and g again, so f is 1, pen's not working anymore, g is cos theta, f dash is 0, g dash is negative sine theta, and g squared is cosine squared theta. So writing out the formula again, we have g times f theta, so g times f dash minus f times g dash over g squared, so that's equal to g, which is cos theta, times f dash is 0, so that's gone, minus f, that's 1, times g dash, so that's negative sine theta, over g squared, that's cos square theta. Okay, so 1 over cos theta differentiates into negative times negative is positive, so it's sine theta over cos square theta. That's what it differentiates into. So let's copy that and paste it down here so we can keep working on it. So that is the derivative of the length. So you might ask, well, why did we differentiate it? We differentiated it because we know that the maximum or minimum of a function occurs, of a function, so we can just say of y, of L, occurs when the function, the derivative, the differentiated function is equal to 0. Right? The maximum of a or minimum of a function occurs when the derivative of the function is equal to 0. So we can now set this to 0 equals negative 3 cos theta over sine square theta plus sine theta over cos square theta, and we now need to try and solve it. Find out what theta is. Okay, so that sounds pretty difficult, but let's find an easier way. So the first thing I'm going to do is I'm going to multiply both sides by sine square theta. So I'm going to go sine square theta times 0 equals sine square theta times negative 3 cos theta over sine square theta plus sine theta over cos square theta. So you can see that on the left hand side it's still equal to 0, and on the right hand side, the reason why I decided to multiply by sine theta is because it will cancel out with sine square theta on the bottom of that first fraction. So I will get negative 3 cos theta plus sine cubed theta over cos square theta, right? Because I have to expand this bracket. So sine square theta times the first term, the sine square theta cancels out with what's on the bottom to 1, so therefore I'm left with negative 3 cos theta on the top, plus this term multiplied by the second fraction, and that gives me sine cubed theta on the top and cos square theta on the bottom. And now I'm going to multiply both sides by cos square theta. So cos square theta times by everything on the right, plus sine cubed theta over cos square theta. So then I will get, on the left hand side, still equal to 0. On the right hand side, if we multiply this out, we will get negative 3 cos cubed theta plus sine cubed theta, right? Because cos square theta will cancel out with the cos square theta on the bottom. Well, rather than cancelling out, you should say cancel down to 1. So therefore I have sine cubed theta on the top. Okay, so now we're very close to solving this. Let's try to move the 3 cos theta to the left. So 3 cos cubed theta equals sine cubed theta. And let's now divide the cos cubed theta on the right. So 3 equals sine cubed theta over cos cubed theta. And you can see that this is very close to sine theta over tan theta cubed. Actually, that is what that is. So let's rewrite it as that. So that is equal to sine theta over cos theta cubed, which is, if you guys remember this equation, sine theta over cos theta equals tan theta, right? Similar to tan equals opposite over adjacent. So therefore this is tan cubed theta. Alright, well tan theta cubed is the same as tan cubed theta. Actually, I probably should write it out so you don't get confused. So therefore, okay, what is all of this saying? This is saying that 3 is equal to actually, I can probably rewind to here. Probably don't need that extra step. So 3 is equal to tan theta cubed. So therefore, tan theta is equal to the cube root of 3. And then we can simply type it into the calculator. Theta is equal to inverse tan cube root of 3. And just type that into the calculator. And if your calculator is on degrees, it'll be 55.26 degrees. Okay, or if your calculator is on radians, 0.964 radians. Right, which makes sense because pi radians, 3.14 radians is 180 degrees. So 0.964 radians will be about 55 degrees. Okay, so now let's substitute that degree into our length equation, the original length equation, which was length is equal to, okay, let's go back up to the top. Length is equal to 3 over sine theta plus 1 over cos theta. Okay, so if we substitute that in, oops, copy the wrong one. Length is equal to 3 over sine theta plus 1 over cos theta. So if you type that into the calculator, 3 over sine 55.26 plus 1 over cos 55.26, you will get 5.406 meters. Okay, and that is the length, right, where we get the minimum length. Now, who has noticed a small mistake? Now, the mistake is that we didn't check that this length is the minimum or the maximum. Okay, we don't have that information. We know that this is either the minimum or the maximum, but the way that we can check to see that this is the minimum is we can find the double derivative of the length. Okay, so the second derivative. So if we have the length is the derivative of the length is this, let's copy and paste that again. So that is the derivative of the length. Alright, if we find the double derivative or the second derivative, okay, and what we can do is use that to say that if the second derivative is bigger than 0, then it's a minimum. If the second derivative is smaller than 0, then it's a maximum. Right, using the second derivative rules. If the second derivative is positive, then it's a minimum. If the second derivative is negative, then it's a maximum. So let's find the second derivative using the quotient rule again. So I'm gonna skip all the algebra stuff because you're probably falling asleep now. But you can see that the bottom is going to be sine. Actually, let's write out the quotient rule again. So there's a quotient rule. I'm just going to use that. So the bottom squared, so that's sine theta to the power of 4, and then on the top I have g times f dash, so -3 sine square theta times f dash, so f is -3 cos theta, so cos differentiates into negative sine, so it's 3 sine theta minus wow, this is going to be a long equation. I'm just going to do it super quick so that your eyes won't hurt. Minus f, so that's -3 cos theta times g dash, so that's sine square theta, sine theta squared dash, so that's 2 times sine theta times cos theta, so it's 2 sine theta cos theta. Okay, that is the left hand side fraction, and the right hand side fraction is just plus. Okay, again, cos to the power of cos theta to the power of 4 on the bottom, and on the top I have, okay, f times g times f dash, so cos square theta times f dash, so sine differentiates into cos, minus f, so sine theta times g dash, so cos square theta cos theta squared dash is 2 times cos theta times negative sine theta, so that's -2 cos theta sine theta. Okay, very long equation. You're probably super confused, but you can probably just check with a graphics calculator if you're allowed to use that in the exam. But anyway, let's now substitute in our theta value of theta value of 55.26 into this super long equation, and I'm just gonna type it straight onto the calculator and show you the answer. And L double dash I have found to be 9.16, which is bigger than 0, so L equals 5.406 is a minimum. Okay, thanks for watching, guys. Hopefully you made it through this. See you next time.